Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome all. In our lesson today, we are going to talk about solving inequalities, and this is in chapter 1, lesson number 5. The objective of this lesson is to solve and graph inequalities. Okay, so to solve and to graph the inequalities. Inequalities. Here we have some examples about the inequalities, and we have these are the symbols of the inequalities. We will use x greater than 3, and here is in word, so we can read it. X is greater than 3, and this inequality, x is greater than or equal to 3. X is greater than or equal to 3. And for this inequality, x is less than 4, and here is the statement, x is less than 4, and the last one, x is less than or equal to 4. Okay, graphing the inequalities. Here we have the first inequality, which is x is greater than 3. We can graph it on a number line using the colored line like this. Okay, so when you have x greater than 3, starting with number 3, here is 0 1 2 3, so starting from number 3 to the right, because we know that the number line, the values on number line is increasing when we are going to the right. Okay, so we have here 0 1 2 3 4 5, etc. So starting from 3, because x is greater than 3, but remember that number 3 is not included in the domain of this inequality, so we should graph open circle. That means number 3 is not included in the inequality or in the domain of the inequality. Okay, and the second one, x is greater than or equal to 3, and the same thing with the first one, but it's different because we have here an equality sign, so we will not write or graph open circle, it will be closed circle. That means number 3 is included in the domain of this inequality. For number 3, x less than 4, and starting with number 4, but we have to graph open circle on number 4 because it's not included. Then going down to the left, because the numbers is decreasing when we are going to the left on a number line. So x is less than 4, it means 3 2 1 0 and any number between them, etc. So we will start graphing from number 4, but remember that open circle because we don't have an equality sign here, so we're starting from number 4 with open circle and going down to the left. X is less than or equal, here's also we have the inequality sign here, x is equal 4, so starting with number 4 but with a closed circle. And here we have example what inequality represents each of the sentences. So we have sentences or statements, and we have to change them to mathematical expression using the inequality sign with variables, with numbers. What we have, number 1, two fewer than a number is at least 5. So the least number here is 5. Then we have numbers greater than 5, and you know that how to find 2 fewer than a number because this is algebra. So we have x minus 2 is greater than or equal 5, because 5 here is the least number of the expression of all numbers. So we have 2 fewer than number, x minus 2 is at least 5, that means 5 is the least number of the numbers, of all numbers. 3 more than a number and is at most 8. Okay, so at most 8 means that the number 8 is the most number or the greatest number. Then 3 more than a number is x plus 3, and less than 8. less than or equal 8, because 8 should be the greatest number here. Properties of inequalities. We have the first property of inequalities. It is transitive property. When we link up inequalities in order, we can jump over the middle inequalities. This is the description of the transitive property. And here we have, if A less than B and B is less than C, then A is less than C. So this is the transitive property. If A less than B, here you have A less than B, and at the same time B is less than C, then A is less than C. Okay. Also, if we have A is greater than B and B is greater than C, then A is greater than C. We call this property transitive property. Example: if Alex is older than Billy and Billy is older than Carol, so Alex must be older than Carol also. The second property is addition and subtraction. Adding C to both sides of an inequality just shifts everything along and the inequality stays the same. If we have A less than B, then if we add C to A, we should add C to B also, and the inequality will stay. Nothing is changed on the inequality. Okay. Example: when Alex has less money than Billy, if both Alex and Billy get $3 more, then Alex will still have less money than Billy. And here we have, if A less than B, then A minus C less than B minus C. This is the same with the addition. The subtraction, the same with the addition. If A is greater than B, then A plus C greater than B plus C. So nothing changed for the inequality sign or for the position of the numbers. If A greater than B, then A minus C greater than B minus C. So we have here A less than B or A greater than B. So if we add or subtract anything from the inequality, so nothing will change. So adding or subtracting the same value to both A and B will not change the inequality. Okay, remember that, addition and subtraction. But for multiplication and division, when we multiply both A and B by a positive number, the inequality stays the same. But when we multiply both A and B by a negative number, the inequality swaps over. That means you will change the position of the numbers. And here is the example with the graph. Notice that here we have, if we have A is less than B, and let A be 2 and B be number 3. So you know that 2 is less than 3. Now if we multiply by positive number 3, so 2 times 3 will be 6, and 6 and B, which is 3 times 3, will be 9. So they will stay, no change. 6 is less than 9. Okay, it was 2 less than 3. When we multiply by positive 3, we will get 6 less than 9. They keep the position. Okay, no change for the inequality or no change for the numbers. They will stay less than. Okay, but here we have the same number 2 with the 3. If we multiply by negative 2, so we will get negative 6 and negative 2 and negative 4 and negative 6. And you know that negative 4 is greater than negative 6. So the sign of the inequality will be changed. Logically, okay, will be changed or must be changed. So here we have, notice that A less than B becomes B less than A after multiplying by negative 2. But the inequality stays the same when multiplying by positive 3. And here are the rules. If A less than B and C is positive, then AC less than BC, no change. But if we have A less than B and C is negative, then AC greater than BC. You see, we change less than to greater when we multiply by negative number, negative C. Okay, so the inequality swaps over. Positive example, Alex's score of 3 is lower than Billy's score of 7, like A less than B. If both Alex and Billy manage to double their scores, multiply by 2, Alex's score will still be lower. Okay, and this is an example of when we multiply by positive number. Okay, but if the scores become minuses, then Alex loses 3 points and Billy loses 7 points, so Alex has now done better than Billy. Okay, and here we have when we multiply by a negative, then the opposite happens. We change the sign from less than to greater than when we multiply by negative numbers. For this property, the additive inverse, as we just saw, putting minuses in front of A and B changes the direction of the inequality. This is called the additive inverse. If A is less than B, then negative A greater than negative B. That means we multiply by minus 1. If A greater than B, then negative A less than negative B. This is really the same as multiplying by negative 1, and that is why it changes direction. And this is the end of our lesson today. Thank you very much.